Hi, everyone. Welcome back to Unscripted Coding. Today, this episode really continues on from a previous video, so be sure to check out part one linked in the description before continuing on. If you are joining for the first time, the really short summary is that we decided to take one of these, which is an Arduino Pro Micro, and wire it up with one of these on the side here, a Bluetooth shield called the HC06. The idea here is really simple. The Arduino Pro Micro is part of the Leonardo series, and what it can do is it can actually connect to the computer and act like a regular keyboard and mouse. What that means is that the computer sees it and sees it as just, a really basic human interface device. What it doesn't know is that there's a Bluetooth module connected to it. And so what we're actually going to do is create a desktop application to send commands to your mouse and keyboard and be able to control it remotely. If you're wondering why am I doing all of this, I guess the scenario I have in mind is the idea of a government computer. Government computers, or even like a big organization that's kind of old fashioned, has like really lockdown security. They don't let you install different programs. They won't let you write macros. They won't let you write code. Basically, they lock it down so you have very limited options to do things automatically on your computer. With one of these, we kind of take it out of their hands. They just can't control this. You connect this, they just see a regular keyboard and mouse, and instead you are sending the commands through another computer. Now, naturally, that's going to have all sorts of problems. It's going to make it it's going to make it harder to actually do any automation on computer, but it makes it possible at least, because now you have connected what they can't really detect. And I know if you go in the comments, there are some really, really convoluted methods where they might be able to see it. But realistically, I think this is a hardware based solution that they'll have a really, really difficult time finding out and trying to stop. Anyways, before I actually continue on to building this, couple of things. Number one, it's really, really important to leave comments, and better comments than these ones, in your code, because it has been a couple weeks since part one, and I have to figure out exactly what I did because I generally leave really poor notes. Number two, quick tip, if you were watching an earlier video of mine, I replaced out the Arduino Pro Micro, but if you ever need to solder headers onto these chips, a really good way to do it is put the header right onto your breadboard, then put your Arduino or whatever board on top of it and solder. I had it all crooked before, and now it's nice and lined up. And finally, the last kind of housekeeping thing is I got a big box of electronics. Well, I guess it's tiny, but actually there's a lot of stuff in here when you consider they're all like this small from China. And what's really awesome is I got these new Bluetooth modules. So instead of the HC06, I think it is called the HC10 now. And look at this. They look basically identical on the back. You just unplug it, the old one, and you plug in the new one. Oh, actually, no, I lied. Oh, Yes, they are the exact same pins. They look exactly the same on the back. This one has actually removed the outer two pins for whatever reason. This old chip was very old. And basically, it moves me from Bluetooth, classic to supporting Bluetooth low energy. So that will be really helpful in trying to make this all work nicely. I do have to change the MAC address, I think. I do have to make some minor changes to code to make sure this works, but it's almost a unplug replug. Besides, nobody is going to buy one of these anymore. I bought it many, many years ago, so you should go with the way of the future. HC10 will give you better I guess, longevity, better connection, and all of that. Anyways, I'm going to stop talking. I'm going to review my code and make sure that it works with this new Bluetooth module. Okay, so ignore everything I said before about this HM10, not HC10, Bluetooth module. I still think, like, if we got it, it should be an easy switch over and it should work, but it seems like the HC10 or AT09 or whatever you want to call it has a lot of clones, different revisions, and a lot of bad matches. And sadly, I just spent far too much time trying to get it working, so I just stuck in the HC05 again, and everything works as intended. And lucky me, I bought a big bag of these, so they don't work. The other thing I want to talk about is what have I been doing all this time? What's happening here? Well, we stopped the last video because we were basically moving these coordinates, and these were randomly generated from my computer to the Arduino through Bluetooth. In theory, that should move over perfectly fine. We get it. We stick it into whatever we want to do with it. And when we look at just what bytes were coming in, nothing was being lost. The Bluetooth connection is fine. I think I was wrong to blame the Bluetooth connection. What I think is actually the problem was using the string and now using the integer, trying to convert a set of characters to an integer. I think the problem is memory. These microcontrollers, you can see there's 28,000 bytes, there's 2,500 bytes or so of space. You don't get a lot of room to do these conversions. It's not a computer with gigs and gigs of memory or terabytes of storage. So what's happening, I think, is it's getting corrupted. You're losing bits and pieces along the way as we're doing that conversion. And so suddenly you have 1-digit numbers, 7-digit numbers, whatever. That is frustrating, to say the least. I gotta do a bit more testing. Hopefully we can get this running fairly quickly. And we're all done another project. I know it looked like I stared at the screen for a while, but what I was doing was actually looking at my other screen, because the one you're looking at right now is screen number 2. So when I use this to anchor to the top right of the screen, it's actually another 2,560 pixels more that way. And so it's far off over here. But I thought I would just explain it to you guys. You've seen my mouse cursor jump around enough to understand how this works. I just want to go through the code and let you guys understand what's happening. So again, I am not going to do a whole lot on the Python side of this. Right now, we've just generated 2 coordinates between 1,000, 1,000, and 1,000. What am I saying? Between 0 and 0 and 1,000, 1,000. That gives it about a square, something like this. Well, actually, probably less than that. Something like this. Sorry. I hope you guys can see the cursor, but somewhere like here in this area is where the mouse will jump left and right. The reason why I don't want to go further into this is because I think that is a project all on its own. Generating these random coordinates is probably enough for proof of concept, but I have seen something called input, PYNPUT, where when you import the package, you can actually detect where your mouse is. It makes no sense for me to demonstrate that here because every time I move my mouse to trigger this and my Arduino's plugged into the same screen, it'll just move right back to where my mouse is, meaning it won't move at all. So if you guys want to see how that looks, here you go. That's exactly how it looked. Exactly the same movement as you would expect as I move my wrist here. So sending random mouse coordinates will do fine just now. The trick here is actually how we move to an absolute location. And so it seems like there is a library that or a solution that will make it an absolute, but what the library Arduino ships with does is it's relative, meaning if your mouse is here and you go 100, 100, it moves up here, 100 pixels to the right, 100 pixels up. I think that's right. No, 100, 100 will bring it down. So 100 pixels to the right, 100 pixels down, so down this way. What does that actually mean? Well, it means that it's very hard to mirror what is happening because when we look at where a mouse position is, you're getting an absolute value. This would be about 1,000, 1,000. I pass it over. If I just move relative, it goes to another 1,000, 1,000. I gotta figure out where I am here, do something clever to move it back up and whatever. This is what all these for loops are. This first one is just moving as far to the top right, top left. I'm terrible with directions, but top left as possible. It just keeps going, and you know how your mouse doesn't go off the screen. I mean, I have a second monitor, so it goes off screen, but in theory, if I anchor it to the top right instead, it doesn't go any further. It's always just at that very topmost point, and then you can let that go. And so that's what I'm doing. I'm just moving it all the way to the top left, just running it, this movement, I don't know, 30 different times. Now, what's interesting about the mouse library and absolutely frustrating is apparently the maximum amount of movement you can do is 128 steps. Why anyone would put that limitation, I have no clue. I get that there are memory limitations, but what use is moving 128 spaces when all monitors now are at least like 1080p? So, 1,000 pixels up and down, you gotta move it 10 times just to move it to the bottom. Anyways, rant aside, we anchor it to the top left, and then we adjust for the X coordinate, then the Y coordinate. Okay, let's break this out. The X and Y coordinates are exactly the same, but again, our limitation is 128 pixels. So what I'm doing is dividing it, setting it as an integer so you don't get that point something. And so let's say it's 1,000 divided by 90. My mental math isn't great, but something like 11 point or 10 point something. It'll just drop down to 10. And so we run it 10 times. 127, once, twice, 3 times, 4 times, 10 times. And then we use the remainder over here to get those last, 30 pixels, 40 pixels, whatever it is. And so you get exactly how many broken up to maybe 10 or 11 different steps. And we do the exact same thing with Y. It is absolutely convoluted, but hopefully these loops are actually pretty straightforward. I think the concept of it is the other piece. The coordinates we were sending are coded because we can only send one byte at a time through Bluetooth. So my Arduino is getting X0439, Y0574Z. They're not getting this string. They're not getting 439. They're getting one digit at a time. And so what we're doing is we're just saying when we see the X, we know that this is the X coordinate. When we see the Y, the X set is going to be the Y coordinate. And then when we hit the Z, it is the end. That is the termination, and that's when we run all of our logic. And in between the X and Y and then the Y and Z, we're just logging each of these digits into the character array. Not this one, but the AA and BB. And then we use this A-toy conversion to get it into an integer, and then we run this little mouse thing. So in theory, this is pretty straightforward, I think. If you were trying to think of it on your own, this for a beginner, this is a bit difficult to wrap your head around. But once you kind of click and get what is happening, I think the code is pretty straightforward. So I'm gonna put this up on GitHub because I don't want to have to deal with this again. This whole for loops. But other than that, I think we are, we've done what we've set out to do. On the Python side, we're sending this, we're broadcasting the random digit over Bluetooth. Pi input, pinput is actually, it looks really, really simple. So it's like a 3-line adjustment to turn these random integers into actual coordinates. But I can't really demo that for you guys, so yeah, I'm just gonna stop here. This was difficult. I hit a number of issues I didn't expect. One of them being the hardware. I thought, buying shiny new hardware, that'd be great. Another one is all this memory, all this conversion thing. I don't normally work with microcontrollers, so these limitations just don't really exist elsewhere. But they do here, and you gotta wrap your head around it. So if you can't tell, I didn't have the most fun doing this one. But now that we're done, we can move on to the next project. So if you like this video, if you like the code, if you like the idea, do comment, do give me a thumbs up. Do subscribe. We have new exciting videos. Next time, hopefully it'll be something a little more exciting, a little less, hopefully the mistakes are more entertaining and more challenging than just physical reality. So do subscribe, hit the like button, comment, and we will see you.